All right, students, good to see everybody. It's Mr. Varner, your fave. I'm your fave. Here, here, Granby. I forgot which side the emblem was on. Gucci. All right, actually, FUBU. All right, so what we're going to do today is we're going to go over these equations that were actually part of a earlier quizzes activity. So the classroom that I had, the classroom members, we didn't do so well on these questions. So we're going to go through them now so we understand how to solve these problems. So this is solving for a variable. And so first of all, I want to give a little context here. So let's do that. We'll go with text. All right. So um, two words I want to go with very quickly. I'm going to go with coefficient, and I may have spelled that wrong. I have a learning disability in spelling. Spelling is one of the areas I have challenges with. So, yeah, you're going to catch some mistakes, okay? And variable, BLE. Are those the only words we're going to go with? Yeah. Variable. All right, so we'll go coefficient and variable. So, if I had, let's say I had a problem I was working, and it was let me change the color. Let's say it was 2x. Okay, so we'll start here. This is the variable, and this is the coefficient. And 2x actually equals 2 times x. Whenever you see the letters right next to each other, they're telling you they're really being multiplied. So 2x is actually 2 times x. If you were going to write it out in language, it would be 2 times x. Now, we use the word x because we don't know what x stands for right now. X could be 3, x could be 15. Let me give you an example. If it was 2x, and let's say that we know it's going to be 2 people, but we don't know how much the movie's going to cost. All right, so we're trying to budget for a movie. So you and me are going to a movie, and we're trying to figure out how much money we need to buy the tickets. Well, if we go to the theater on Lynn Haven, the tickets are going to be $8 a piece. If we go to the movie theater at Military Circle, the tickets are going to be $6 a piece. So 2x. X is the variable. It's going to vary whether we go to Lynn Haven or if we go to Military Circle. So 2x. If we go to Lynn Haven, 2x is 12. 2 times 6, the price of the tickets at Lynn Haven. Well, I think it's 8. Whatever the number is. Let's say Lynn Haven is 6. Military Circle is $5 difference. Okay, so if it's 2 times 6, that's going to be $12 we need to have if we go to Lynn Haven. If we go to Military Circle, then we're looking at 2 times 5, which is $10. So that's why we look at variables, because things can change. All right, so let us move on. Okay, so I erased the wrong thing, and I can undo it. Let's see if I can undo it. There we go. I'm gonna have to leave that there, I guess. Okay, so let's go to problem number one. Problem number one. All right, so with problem number one, x plus 7 equals 12. Okay, think of it this way. You need to pay $12 to go to that movie at Glen Haven Mall, right? All right, so it's going to be $12. You have $7. How much money do I need to come up with so we can go see the movie? You have $7. How much money do I need to come up with? Mr. Varner needs to come up with, and don't say the whole 12. I'm not treating you. How much do I need to come up with so we have the $12? Well, this is how we handle this. All right, so x plus 7 equals 12. Now we have this thing that we call the inverse operations. So I'm going to leave that right over here. I'm just going to leave that right there. All right. So the inverse operation. So the inverse of addition is subtraction. All right. The inverse of multiplication is division. It's the opposite operation. So look, plus, minus, times, divide, those are all operations. And on the other side are the inverse operations. Okay, so to solve this problem, what we're going to do is we're going to do the inverse to make sure that we get the variables on this side and we get the constants on this side. Now, what am I saying? The variables on this side, the variable would be, once again, the letter, the thing that can vary. So we want the variables on this side, and we want the constants on this side. The constants are numbers that aren't changing. They're constantly 5. It's constantly 10. 15 is constantly 15. It is not changing, okay? So we have the variables on what side is that? That's the left. And the constants to the right when we're solving these problems. It's going to change a little later on, but for now, that's what we're rolling with, okay? So to do that, we're going to subtract 7 on both sides of the equal sign. Now, the equal sign are like two different lands. This is the variable land. This is the constant land. Variable land, constant land. So we're going to do the same thing on both sides of the equator or equal sign. Okay. All right. So look, positive 7 minus 7. If you had $7 and you lost it, now you have 0. So all we have to do is bring down our x, because positive 7 minus 7 is going to be 0. If you had $7 and you lost it, now you have $0. Hopefully you're not broke as a joke like that, but it happens. I've been there. 12 minus 7 is 5. If I had 12 and I subtracted 7, it's going to give me 5. So now I know that x is 5. And so x is 5 would have been the correct answer. All right. So you see how we worked that out? Do you see how we worked that out? Hopefully you saw how we worked that out. And we're going to hold up and we're going to hold on to the inverse operations here. As a matter of fact, let me title that. I'm going to title that inverse operations. Okay, so those are inverse operations. Plus, addition is an operation. Minus is an operation. Oh man, the sun feels so good today. Just, I'm at Varner Beach. Yeah, I own my own beach. I'm in Varner Beach. Yeah, you have to pay to come here. Yeah, that's how I do it. Okay, and so plus is an operation, minus is an operation, multiplication is an operation, division is an operation. Let us move on. Let's try this next one, okay? All right. Yeah, so, okay. Solve this equation. X minus 4 equals 6. Well. All right. Now, I always rewrite the equation because it helps it sink into your brain better. Trust me. The more you interact with something, the better you get at it. The more you play Xbox, the better you get at Xbox. The more you play basketball or football, the better you get at it. Okay, so x minus 4 equals 6. Now, what are we doing? We're going to do inverse operations to solve for x. We're going to do inverse operations to solve for x. So we want the variables on the left. We want the constants on the right. So what do we need to move on this side of the equal sign? On this side of the equal sign. What do we need to move on this side of the equal sign? What do we need to move? We need to move the -4. So how are we going to move the -4? By using the inverse operations. Okay, and some of you picked that up already. So we're going to move quicker. What's the inverse of plus? Minus. So what's the inverse of minus? Plus. So we're going to add 4 on both sides of the equal sign. -4 plus 4 will give you 0. So they actually kind of just cancel out. And then you bring down your x. Okay? And 6 plus 4 is 10. So we see, oh, it's 10. That's the answer. That's the answer. So you see the process that we're going through? It's not going to change a lot. We're going to use inverse operations to solve for a variable, to figure out what that variable is. We're going to use inverse operations to figure out what a variable is. And let me give you a hint. Let me give you a hint. All right. So I'll go with this color. D C U U. All right, D C U U. And I'm also going to put a parentheses around the D. Okay. I'm going to put a plus or a minus sign next to this U. And with this U, I'm just going to put a division sign. Now, I'll tell you why I did that in a little bit, but we won't need it for this one. We just solved this problem. Let's go on to the next problem, okay? 4p equals 16. 4p equals 16. And so 4 is the coefficient, p is the variable, right? 4 is the coefficient, p is the variable. So let's solve this one. All right, so as always, I'm going to rewrite it because it sinks it into your brain a little deeper, okay? So 4p. Now, 4p is really 4 times p, right? Right. So what's the inverse operation for multiplication? It's division. So we're going to make a fraction under the 4. You see, the fraction is under the 4, not under the 4p, not under the p, just under the 4 for a reason. And on this side, we're going to make a fraction. Okay, so 4 goes into 4 one time. I'm making the 1 really small. Because really, if you have p, that really means 1p. So I'm making the 1 very small. And in your handy dandy calculator, you'll see that 4 goes into 16 4 times. So here's the answer. Here's the answer. Yep. Yep. That's the answer. All right. So see, I'm expecting you to do this with me. So we're going to go on to the next problem. We're going to boogie on over to the next problem where it's lit. And oh, I didn't want that to happen. We just solved that problem, didn't we? We just solved that problem, didn't we? All right. Okay, well, we can do it this way. I didn't expect that to happen, but let's see if I can click off. Okay, we'll do it. All right. All right, so this was the toughest question. Y equals 33 equals 147. Okay. Okay. All right. Well, I want to make sure that we have our inverse operations. Remember, the opposite or the inverse of addition is subtraction. The inverse or opposite of multiplication is division. So I'm looking at this problem and I want to have, as you see, I want the variable on this side, the constant on this side of the equal sign. So what do I need to move on this side of the equal sign? So I have the variable by here by itself, and I have the constant, the numbers by itself. I need to move the negative 33. Absolutely. So I'm going to subtract. Oh, what's the opposite? The inverse of subtraction is addition. Yeah, some of you caught that. Hopefully I caught it in time. Okay, so I'm going to add 33 on both sides of the equal sign. Okay, so negative 33 plus 33. If you owed somebody $33 and you paid them, now you don't owe them anything. They're out of the way. Bye, boo. You know, bye. Get just gone. You know, gone, girl. All right, so they don't owe you anything. You don't owe them anything. So now we have y equals, now 7 plus 3 is going to be 10. So I'm going to put my 0 here, carry my 1. 4 plus 3 is 7. Plus 1 is 8. And I'll bring down my 1. So 147 plus 33 would be 180. And when we played it, only when we did this quiz, only one of our students got it correct. Okay, so that's good. That's good. We'll do one last one. We'll do one last one. Are you ready? Are you ready? Okay, this is, okay. What is the inverse operation of division? All right, so if we look on our chart here, if we look on our chart, the inverse of addition is subtraction. The inverse of multiplication is division. So what's the inverse operation of division? The opposite or inverse of division is multiplication. And as you can see here, the correct answer was multiplication. Okay, good. So that shouldn't have been a long question, but it was. Now, DCUU, which means distribute, combine like terms, undo with addition or subtraction, undo with division. We'll use that a little later on. I just wanted to introduce it right now. And actually right now, all we've been doing would be the bottom part. We've been undoing with addition and subtraction, and we've been undoing with division. All right, let's go to the next problem. What is the inverse operation of, should have been just one what. They made a mistake. Mistakes happen. Okay, what's the inverse operation of subtraction? Well, that's easy. The inverse operation is addition. Here's addition, and here's this inverse subtraction. The inverse operation of subtraction is addition, right there. Let's go to the next one. Solve the following equation. So you can do this quickly. Okay, so all you're going to do is subtract 8. Yep, you're going to subtract 8 from both sides. You're going to subtract 8 from both sides. All right, so plus 8 minus 8, you had $8, you lost it. That happens. All right, so now you have x equals 15 minus 8 is going to be 7, which is the correct answer. Okay, so we've solved these problems. Yeah, we did a good job in solving the problems. All right, so that gives you an idea of how we should solve for x. So hopefully that helped you. Watch the video again if you need to. Try to do the problems before I do them. I'm going to sit back and enjoy the sand, enjoy the beach at Varner Beach. Yeah. Hey, salute all the comments. Yeah, the comments. I forgot where it was. I'm really Superman. Bye.